Hi, we're presenting as Group 2. Our group consists of Melissa, Viba, Bhargavi, and I'm Sydney. We'll be predicting Airbnb prices in New York City. So everyone is familiar with the world's largest accommodator that doesn't actually own any real estate. But how could predicting listing price add value? Being able to adjust price dynamically based on times of the year and demand allows Airbnb to create what they call their market pricing available to hosts. And this ensures lower prices to meet demand during low seasons. It ensures high prices to meet demand busy seasons, which allows them to maximize profits for hosts and Airbnb. This is a visualization of the data set that we used and uploaded into Databricks. There's a little under 49,000 rows, each representing an Airbnb listing in New York City. There's 16 columns, which each represent a unique feature of a single listing. This is a visualization of our data flow, of where we uploaded the raw data, created the features and labels, and went through data pre-processing and cleansing in order to train and validate the model prior to running our test data set through it to predict the labels. Next, I'll turn it over to Viva to discuss the source code and components.
Hi all, this is Vibha. So we have focused on four high-level components. For pre-processing, using the PySpark functions, we have to convert some of our columns from string to integer to do the regression analysis. We have also looked at the null and empty values or empty values in the integer columns as well, and we have replaced those with the default none values or zero values for integers so that we can make use of all of the data rows. So for visualization, we have used bar graphs and box plots to understand the data and how the price is varying based on the various independent variables like neighborhood groups, number of nights, number of reviews, etc. Here is a screenshot of the box plot of price against the neighborhood group, and we can see like some of the neighborhood groups we have like higher prices and others are like on the lower side. And you can see like we are representing our data as well here. This is a screenshot for the integer columns, and we have same for our string columns as well. For data modeling, we are using linear regression. Here is the little sample code which is showing how we have like our independent variable against our label column, which is price. So for independent columns, we are using minimum number of nights, number of reviews, calculated host listing count, and availability 365. These were like integer columns. Then we have used a string indexer as well to convert a neighborhood group so that we can make use that as well in our model. And we are using vectors and pipelines to include all those independent columns and fitting our model. For evaluation, we have used mean absolute error, root square error, and the root square mean error to show our results. That's all for the source code. And for demo, I'm handing over to Melissa.
Thank you, Viba. This is Melissa Diaz, and I'll be demonstrating the source code. I've loaded our data, created the cluster, and you can see that I've loaded the Python notebook. First off, we begin by creating the data frame and loading the CSV file. One thing I would like to note, we did run into some challenges with the name column. There were a lot of special characters, and even after cleansing, we had some challenges there. So we did remove that out of our CSV file. You can note that we did infer the schema. Everything then was loaded in as string, which then we had to convert the appropriate columns to integer. And displaying our schema, you can see the final result here of those conversions. We then go into our data visualizations. And as you can see, this is our data profile and shows you some of the challenges around some of the fields by highlighting them in red. So it splits between numeric and categorical features. And it shows here in red, for example, number of reviews, 20.56% of the data contains zeros. So that does give you some indication as to some of the pre-processing and data cleansing that needs to occur. Next, we go into that data cleansing section. First, we get a count of our null, none, or NaN values across the different features. We then do cleansing on them. So for neighborhood groups, we change the value to none. And then for anything that had empty string in our integer values, we change those to 0. Next, we go into our modeling and configuration section. We use string indexer to convert a categorical column to hold numeric data on neighborhood group. We define our vector assembler. This will create our vector of input features. We define the pipeline of the string indexer followed by the vector assembler. We then go into our train test split. We use 70-30 and we seeded it with 42. We run the train data through the pipeline, and then we will go through fitting the train data. We then initialize our linear regression model. One thing I wanted to note, we did do some iterations and trying to come up with better results in our model by altering some of the parameters from the default values. We did not see a lot of improvement though. This is followed by fitting the model on the train data. Then we go through the test data and transforming it through the pipe, and then finally fitting the model with the test data. So this is followed by our evaluation of the model. So I'm going to go ahead and run all the cells from this point below to regenerate our results. First, we show our residual values. We go through our mean absolute error, R-squared, and root mean squared error, and this will give you an indication as to our baseline price value. That's the end of the demo, and I will turn it over to Bhargavi.
Thanks, Melissa, for taking us through the code. The results that we have for this is R squared, mean average, and root mean square error. Since this being a linear regression model, we need to know, or we need to first look at the adjusted R squared to say that the independent variables and the dependent variable has a value of 3.89% lineage, or it explains that every time there is a variation in the independent variable, there is a 3.89 percentage that has an effect on the dependent variable. And the loss function that we have used here for our analysis is the squared error. And you could see from the root mean square error that the value that we have, or the deviance from the deviance while it is being predicting the values, is $233, which is almost 50% more than the average price that we calculated, which is like the average price is 152 and the root mean square error or error in predicting is 233, which is almost 50% more. This actually makes us think this is not a great performing model because of the error value that it is displaying. It has a wider range of error where there's the average price is actually much lower when compared to the error value. We could actually work on improving the performance of the model by changing the parameters like maximum iterations or ETA, penalty if there is any overfitting or underfitting, or we could have more data samples if we could get hold of it, or we could try to normalize the data by eliminating some outliers or adjusting the skew, or we could use another model to see how the performance of the other model is for a linear regression. I would say we unanimously had the challenge of using the PySpark because this is the first time we ever used compared to Python usage in all other courses. So that was a big challenge for us. How did we overcome is by going through lots of examples that were provided in the classes as well as in the Canvas by the professor. We went through all of that as well as we went through online resources. The next one was the neighborhood group column. This is a string column. So we were trying to figure out a way how we can use a string indexer in order for us to proceed or as a part of the pre-processing step. Again, there was a bit of a challenge because I would say it's rolling up to the PySpark challenge that we had in the previous one. So it's basically how to use the string indexer and which rolls up to the PySpark challenge. The other one that we had is the name. It was part of a pre-processing or cleaning process. We were able to clean all the columns, but we found in this name column, we had a couple of special characters which were mistakenly considering as a delimiter by the PySpark. So we had to clean all the special characters and it was still not loading properly. It was throwing errors or some columns were off. So we had to eventually drop this column even after cleaning all the special characters out, which helped in loading fine with all the data columns. And then the last challenge that I could say is finding a data set. We had lots of data sets. Individually, everybody did lots of other projects. We had lots of data set, but we wanted to have a simpler data set so that our focus would be more on interpretation and how to apply the PySpark and all that. So we agreed to this data set that we use, which is Airbnb data set, which is more familiar data set to all of us. That's how we ended up with this data set. Thank you.